Hi everyone, my name is Jermaine and today we're going to do configuration on HSRP. And as you can see, we have our topology where I have switch 1 connected to router 1 and router 2. So within the 10 addresses, we're going to do HSRP. This is going to be our virtual IP address. R3 and R4 will be your clients, and this is also a switch here which is going to represent our ISP. So let's start by putting the IP addresses on these interfaces. Let's do show CDP neighbor to see what's connected. Okay, so we're going to do interface fast0/0, which is connected to switch 1. Add the IP address. It's going to be 10.100.0.1. And our outside interface is going to be fast0/1. IP address is going to be 100.0.0.1/24. All the networks is actually /24. And these labs that I do are not edited. They're all done on the fly. There's nothing to fix behind the scenes. Everything is just raw. What you see, what you get. So bear with me, guys. Let's do a show CDP. So switch 1. Okay. So my interface fast0/1 is connected to switch 1. 10.100.0.2. And we're going to go to the outside, which is going to be fast0/0. So let's do a quick ping to router 1, 10.100.0.1. Successful. Let's ping from the outside, 0.0.0.1. Successful. So on this switch right here, I'm gonna set up a switch virtual interface, and it's gonna be switch 2. So let's show interface VLAN 1. You see it's down states. So let's bring this up. Let's add the IP address to it. Do no shut to bring that up. And once it's up, let's check for reachability. Ping 100.0.1, which is going to be router 1, and do router 2. So that's good. We have reachability within the switch, outside and inside. I do have switch 1 connected to a switch 3. So let's create this ether channel real quick. So go back to switch 1. Use your favorite friend. Show CDP neighbor. As you can see, 13, 14, 15. So let's go in. Interface range. Fast0/13 to 15. Let's shut those links down. And with channel group 1. Let's do pack P, which is desirable. And do a no shut. Let's go to switch 3 and do the same configuration. Interface range fast0/13 to 15. Do shut. And then channel group 1 mode desirable. So they are both desired to be a part of the each channel. No shut. So remember, R3 and R4 are going to be as our host to test. So let's go to R3, show IP interface brief, show CDP neighbor. Okay, so we're connected to switch 3 on fast 0/1. Let's go to interface fast 0/1, add the IPs. It's going to be 10.100.0.30/24. Shut. Let's exit. And we're going to turn off routing on this router since it's going to participate as a host. So let's do no IP routing. And what we're going to do now is to set a default gateway. Our default gateway is going to be the virtual IP. It's going to participate in the HSRP. So let's do IP default gateway. And we're going to specify the gateway. It's going to be 10.100.0.3. So let's go to router 4, do the same config. Show CDP neighbor to see if it's connected to switch 3. So on switch 3 is interface fast 0/1. IP address is going to be 10.100.0.40. Shut. And we also going to turn off routing on this router also. No IP routing. And IP default gateway 10.100.0.3. So we should have reachability to the 10 network, but we should not have reachability to the 100 network because our gateway is not up yet. So let's do a ping 10.100.0.1. Successful. And ping router 2. Successful. We could try to ping outside. And as what I said before, it can't go out because the default gateway is not up yet. So what we're going to do is to turn on HSRP and router 1 and router 2 connected to switch 1. So show CDP neighbor again. Okay, so this guy here. So interface fast 0/0. We're going to issue the command standby, the group number, and IP. It's going to be 10.100.0.30. Sorry, that 3. And that's it. That's the configuration to do basic HSRP. Nothing special, nothing crazy. You can just do that command and have it work right out the box. But there's a lot of tweaking to be done to get it working properly. So we're on show CDP neighbor. And let's go back to this interface also. Standby 1. You want to make sure you keep the standby number consistent with your router, enable router, because every number is a different process of HSRP. So let's keep it standard 10.100.0.3. And as I said before, that's the only command right now, right out the box. That's it. And as you can look at router 1, it is active right now. And if we go back to a house on R3, just now we wasn't able to ping outside. So if we go back up and ping 100.0.4, we should be able to go out successfully. If we do show ARP, we can see the HSRP MAC address, which is this guy right here. So in your environment, or on a regular PC or anything, and if you ping and you see a ARP request comes again with this following MAC address, most likely you run HSRP, and this is actually the one reference to your group number. So if I should have a different process of HSRP running, like a standby group, standby 2, this will change to 2, or additional MAC address will come. So that's the basic configuration of HSRP. So we could issue the command show standby brief. That's wrong router. Let's go back. This is show standby brief. And from router 1, you see he's a participant in group 1. His priority is 100. His state is active. And his neighbor is 10.100.0.2, which is router 2. And this is the IP address that both R1 and R2 is hosting right now. So what we could do is test the transition state of how fast HSRP went from active to standby, from standby to active. So we're going to issue an extended ping. It's going to be 10. It's ping outside. It's going to be 100.0.0.4. And let's do a count of 100,000. So what I'm going to do right now is to shut down router 1 link connecting to switch 1, and then he should go back in a. Router 2 should become active because his link is down. And how does he know the link is down? Because they send keep alive to each other. They send hello messages, and once there's no response to hello, they then make a transition state. So right now I'm sending ping, and if I go to router 1 right now and go to interface fast 0/0 and do a shutdown, I want to see you guys to see the transition state. So I'm gonna hit enter right now. A route you can see right there. So it's making its transition from standby to active to router 2. And let's see, router 2 is active, but it's still not going through. So that's very interesting, because you can see it says active, and if I do show standby brief, it says it's active. So go back to router 3. So what I'm going to do right now is to ping my host. It's going to be 10.100.0.3, and it is replying. Sorry, not 3, 30. Successful, so I was able to reach it. Well, guys, you see that? So as soon as I actually ping, as soon as router 2 ping 30, that's when the transition continue. Not sure what's going on, because it's not supposed to be like that. And let me double check something on switch 1, where I'm gonna do config T interface range pass 0/1 to 2, which is connected to R1 and R2. And let's do a switch port host to turn on port fast on these links. And okay, so it's still pinging. And let's bring this link back up and see what's going on. So the link is up, still sending pings. Its transition is going to go into standby. It's not going to become the active router because we don't have any preamp feature turned on. As you can see, it's still sending it. So with preamp, the preamp feature basically telling each router that whenever you see a higher priority number comes in, make that router become the active. So by default, both routers actually has a priority of 120. So what I'm going to do right now is actually to turn on preempt on each of these. So once the next time you see any form of changes, it should become active based on the priority number. So what I'm going to do is to increase the priority number to 120, turn off this link, turn it back on, and he should actually have a transition from standby to active right away. It won't be like the last time where this guy was continuing to be active. So let's go back to interface, fast 0/0, and do standby 1. Let's do a preempt, and let's do priority. I'm gonna give him 120. So as soon as I did that, you see where he becomes the active router as soon as I actually turn on preempt and give him a higher value. So right away say, yo, I got the highest values, so I'm going to become active regardless. Doesn't matter if you're sending packets, I'm going to be active. And now he's in a standby state. So that's good, and that's actually also bad, because now if router 1 had something wrong with his link where his link was flapping, he had a flapping link, flapping interface, and his interface going down, then he can become active, and his interface come back up, he's going to be standby and active again. So the changes will be standby, active. So by then, the host won't even be able to send traffic, because his transition is always in a state where this link is flapping. Because we got preempt and he has a higher value, his link is telling me I'll have to go active. So what we could do is to enable preempt, but do it safely by stating that I know that you have a higher value, but I'm gonna put the delay time on your preempt to say that I'm gonna let your link stay for 20 seconds just to make sure, or 10 seconds just to make sure your link is working properly before you become active. I'm not just gonna bring you right up and you becoming active. I'm gonna let you stay for 10 seconds to make sure your link is working, then you're gonna go active. So it's like a fail-safe. So it's better off to have the links flapping back and forth than to put a delay value for him to actually take a time out to get his link, his interface fixed or replaced or whatever. So let's go back to router 1. I think we're already in this interface, just to make sure. And we're going to do standby 1, and we're going to preempt delay. We're going to do a minimum. Let's do 10 seconds. So now, what's going to happen now is that host 3 is going to send an extended ping, and he's going to be the active guy. He's going to go to router 1, go out to the ISP. I'm going to turn this link off right here, and router 2 is going to become active. Right? So now router 2 is going to start handing off traffic to the ISP. I'm going to go back, I'm going to turn this link on. He's not going to come up to be active right away because we put that delay value on the preempt. It's going to wait 10 seconds before his link become active, and then he's going to start forwarding packets. So let's do that and see what's going on. So let's check to make sure he's active. Show standby brief. Okay, yes, and let's go and do an extended ping and do ping 100.0.0.4. So ping IP 100.0.0.4. Let's do 100,000. So we're sending ping right now. Remember, I'm going to shut this link off. And once you shut this link off, he's become active. And we're going to turn this link back on. He's going to wait 10 seconds before his link go back into active state. Then he's going to forward package to the ISP. So let's go see if this works. And let's do a shut. And you can see the transition right there. So now router 2 is active. So now we're going to go back to this interface right here and turn it on back. Shut, no shut. And we're going to watch 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There you go, right here. Right here. So you actually waited 10 seconds, which is good. So now we can use that just to prevent a flapping link. It doesn't have to be 10 seconds because really it's such a troubleshooting process right now. In the real environment, you want to just put 10 seconds. It could give you like 5 minutes, 10 minutes, just to play safe. Whatever your best practice is. So yes, so the preamp actually tells each router the one with higher value is the active router. So the delay gives a time before it becomes active. So my next question is, so packet is flowing to router 1 going out to the ISP. So what if I turn this link on, turn this link off going out to the ISP? Would that sending the message to router 2? Let's go and go in the interface of fast of router 1 going out to the ISP and do a shut and look if there's any transition message. Is there any transition message? Packets? Nope, there's no transition message. Nothing state that the link is outside is down because there's nothing to monitor these links right now. By default, there's nothing to monitor these links. There's nothing special going to the ISP more than just forwarding packets. There's nothing to participate with an HSRP or nothing. There's nothing great going on in these links. So what we could do is to monitor these interfaces and play with the priority numbers. So we could use a feature called track interface, which basically tracks the interface going out to the ISPs, and we could put a decrement value stating that if my priority is 100 or my priority is 120, sorry guys, if my priority is 120 and I have tracking on this interface going here, I'm gonna put a decrement value of say 40, which says if this link ever goes down, I want you to decrement my priority to from 40 out of the 120, which is going to bring me down to 80. And because we got preamp on these links, and preamp state that whoever got the highest priority becomes active, R2 is going to see that his value just came down to 80, and then he's going to go in the transition to active. So let's check this out and see what's going on. Let's do this configuration. So let's do no shut, bring that link back up, and let's do the configuration. So this configuration has to go into the group, standby group interface, which is going to be fast 0/0. We're going to issue the command standby 1 and track fast internet. And which interface will be tracking? The one going out to the ISP. In my case, that would be fast 0/1. So 0/1 and a decrement, and then a decrement value right here. So I'm gonna do a decrement of 40. So right now we could do this again. Where ping target address is going to be 100.0.0.4, and let's do 100,000 again. So now he's sending packets. It's going to his active router, which is router 1. Show standby, brief, active. So now, because we have something special going on the interface, going out that feature, the check interface, if I do shut down this link, it's going to decrement by value by minus 40 from that 120. So if I hit shutdown right now, you're going to see the transition on R2. And let's do show standby, brief. His value is 80. So unreachable, unreachable, unreachable. Show standby, brief. Is the active. Something is crazy going on with this router. It's probably the code. So it's still, it says unreachable. Shouldn't be unreachable because it's now the active, as you can see. Oh, state standby. Why is it still on standby? Let's see if we got preempt on this interface. Config T, interface fast 0/1, and do standby 1, preempt. Okay, so I didn't have preempt turned on, and that's why that happened. So that's a good troubleshooting right there. So now, as you can see, so it did decrement the value to 80, as I showed you right here. R2 did become active based on its priority number. So that's a good feature set to have because there's nothing, we don't have anything talking to the ISP. So if we could have something that could monitor our own interface to send these messages inside to tell us what's going on, that's best practices. I like that feature. So guys, thank you for watching, and I'll see you till next time. Enjoy the rest of your day. Subscribe and share. Thumbs up. Peace out.